Good day, everybody. How are you all doing? Hope you're doing great today. It's bright and sunny outside. Hope the weather at your place is great today. For those of you who do not know me, this is Dr. Nandi. I frequently go live on my channel. I have also recorded a number of YouTube videos on how to solve math problems, different kinds of math problems. So if you get a chance, please take a look at my channel and take a look at the videos that I have recorded to help you work out math problems. If you like my videos, please give me a thumbs up. And if you like it, please subscribe to my channel by hitting the red subscribe button. So without further ado, let's get started. And I really appreciate a thumbs up that really motivates me. So let's get started on today's problem. Says an elevator car can accommodate a maximum of 16 people with a maximum weight of 2,500 pounds. Assume the average weight of a person is 150 pounds with a standard deviation of 27 pounds, and the distribution of weights is approximately normal. That means a bell-shaped curve. Suppose a simple random sample of 16 individuals will be selected to ride the elevator. What is the mean weight of the sampling distribution? That's part A, and part B is what is the standard deviation of the sampling distribution? So let's get started in solving part A and part B first. So I just want to give a brief idea of what we are talking about. We are talking about the sampling distribution. Sampling distribution. Oops, pardon me. So, oops, not so well. So, okay, so I'll take care of this. Yeah, okay. So we are dealing with the sampling distribution. Sampling distribution, okay, of X bar. And the sampling distribution of X bar looks like this. This is the sampling distribution of X bar. So it's a bell-shaped curve also. That's normal, approximately normal. So like this. Okay. So we have X bar on the horizontal axis. Remember, X bar is sample mean on the horizontal axis. And of course, we have probability on the vertical axis. So the center is where the relative frequency or probability is highest. Okay. That's the center of this curve, which is mu x bar is the mean of the sampling distribution of x bar. Distribution of x bar. Distribution of x bar. And sigma x, let me erase that and write it more close to. And sigma x bar is the standard deviation of the sampling distribution. Deviation of the sampling distribution. Here the key phrase is the assume the weights are normally distributed. So if I may draw your attention, it says assume the average weights, assume, uh, assume, where do I go? Okay, let me reduce it. Okay. Uh, Assume the average weight of a person is 150 pounds with a standard deviation of 27 pounds and the simple random sample of 16 individuals will be selected. Okay. So assume the average weight of a person is 150 pounds with a standard deviation of 27 pounds and the distribution of weight is approximately normal. This is the key thing. The distribution of weight, the random variable is weight, is approximately normal. So that means we can write since, let me write it over here. Since the distribution of weights is approximately normal, is approximately normal. This is the key thing. Approximately normal. The the sampling distribution, the sampling, the sampling distribution of X bar is also normal. Distribution of mean weights, of mean weights, of mean weights, that is X bar, is also normal, is also approximately normal, approximately normal, approximately normal, normal. From central limit theorem, central limit theorem, mu x bar, which is the mean of the sampling distribution, sampling distribution is equal to mu, or mean of the population, mean of the population, of the population. Also sigma x bar is equal to standard deviation of the sampling distribution, of the sampling distribution, and from central limit theorem this is equal to, distribution is equal to sigma divided by square root of n, where sigma is standard deviation of the population, deviation of the population, deviation of the population, and n is equal to sample size, n equal to sample size. Now if we move a little bit up, let's see, given, so we're given mu, mean of the population, and sigma, it is given. So if I move a slightly bit up, the okay, the assume the average weight of a person is 150 pounds with a standard deviation of 27 pounds. Okay, So mu is given as 150 pounds, and this is 27 pounds. Hence, sigma x bar is equal to sigma divided by square root of n equal to 27 divided by sample size. And we are also given as n. Sample size is also given to us. So we will go and take a look at the sample size. Okay. Approximate. Suppose a simple random sample of 16 individuals. Okay. So n is 16 given to us. N is 16. So n is 16. 16. So sigma x bar will be 21 divided by 6 square root of 16, which is, sorry, 27 divided by 4. Using our calculator, sigma x bar becomes equal to 27 divided by 4. I'm going to use the TI-84 calculator. Is 27 divided by 4 is 27 divided by 4 is 6.75. 6.75. I just want to make sure that there is this is gone. This there should be anything. Okay, so the part A, if we take a look, part A is what is the mean weight of the sampling distribution and what is the standard deviation of the sampling distribution. So A, so if you answer part A, let's do it this way. Part A, part. Okay, catch it. Oh, that because I have this problem. Okay, so let's see all of this. Okay, so now I go here and part A is mu x bar is equal to mu equal to 150. Part B is sigma x bar equal to sigma divided by square root of n is equal to 27 divided by square root of 16, which we found out as 6.75. Now let's go to part C. So what does part C says? Part C, what mean weight of the sample of 16 people will result in the total weight exceeding the limit of 2,500 pounds. Okay, so we are required to find out the mean weight of 16 people, which will exceed the total weight of 2,700 pounds. Let's make sure of that 20 uh, 500 pounds. Okay, because a elevator can support a maximum of 2,500 pounds. So part C is let's do it over here. Part C, maximum weight is 2,500 pounds. Maximum number of uh, people is 16 people. So mean weight, maximum mean or average weight is 2,500 divided by 16, which I will use my calculator to find out. 2,500 divided by 16 is 2500 divided by 16 is 156.25. So is 156.25. So if the average weight of a person for a sample of 16 size is more than 156.25 pounds, that will exceed the total weight limit. And if you remember in part D, last part, there, what is the probability that random sample of 16 people will exceed the weight limit? That is, their average weight will exceed 156.25. So if I draw the, let's do it this way, part D, we are dealing with sampling distribution of X bar, sampling distribution of X bar. N is 16. Okay. So this is how it looks like. Let's draw it. Uh, okay. So here is the mean, where the peak is the high. This value is mu x bar is equal to, we have already determined, it is equal to 150. So 150 and sigma x bar equal to 6.75. So part D, we want the probability of X bar exceeding 156.25. You understand why? Because there are sample size is 16, 156.25 is the average weight multiplied by 16 people will be just 2500. If it is any greater, it will exceed the limit of the elevator. Okay, the total weight will exceed the limit of the elevator. Now 150 is at the center, so it is 156.25 will be somewhere over here on the right of the mean. Okay, so this point is 156.25 on the horizontal axis, and we want to find what is the probability X bar greater than 156.25. So I'm going to use TI-84 calculator. So in TI-84 calculator, I will press, so let me first, let me erase this. Okay. So let me use a different ink maybe. Okay. And also let's move a little bit up. Okay. So in order to find that, we have to find area. We have to find equal to area under the sampling curve, sampling distribution to the right of to the right of 165, 156.25. Okay. And given mu x bar is 150, mean is 150, and sigma x bar is 6.75. So we are going to use TI-84, use TI-84 calculator. We will do second verse is the key in the third row, number 2, which is normal CDF. So let me bring it over here, is normal CDF. Okay, so I press the second key on the top left and the verse key on the third row. Then number 2 is second key. Then the verse key on the third row. Then number 2, which is normal CDF. Then it asks for a lower. Remember, the lower is where you are going to start your calculation from. Here we are going to start our calculation on the horizontal axis from 156.25. So let me erase that and write it carefully. This is 156.25. That's my lower. So I type in 156.25 and my upper is a very large number on the right. So upper will be, I'll type 1, then I will type the second button, then I will type the comma button, which gives me the small cap E. E stands for exponent. And then I type 99 after that. What does it mean? 1 followed by 99 zeros. This is as if the curve extends to 1 followed by 99 zeros, a very large number on the right. Okay. And the mean I will type is 150, and the sigma I will type is 6.75. Okay, and then I go down to paste and hit enter and enter twice. Enter twice. So let's do it. Mu is 150, mean of the sampling distribution. Sigma is the 1 second, comma 99. Mean is 150. Standard deviation is 6.75. Okay. And I go down to paste, and hit enter twice. And that probability, this probability. So let me move up a little bit. Okay. So, yeah, something like that would do. So, probability of x bar greater than 156.25. That means what is the chance that the total, that the average weight of 16 people, will exceed, will, will exceed 2,500 pounds. This is what my goal is, to find the average weight of 16 people to exceed. This is the total weight. Average weight, let me clarify that. I'm dealing with average weight. That means I should erase this. Average weight will exceed 156.5 pound. So will exceed 156.25 pounds. Oof, let me write it correctly. Will exceed 156.25 pounds. That means the total weight will exceed 2,500 pounds. And that probability is that probability is x bar greater than 156.25 is, according to the calculator, 0.177 or 17.7% chance. That means in 100, about 18 times it will exceed the 2,500 total weights, or 156.25. Okay, not change, it is chance. 17.7% chance that if you put 16 people and do it many times, or 100 times, out of 100 times, 17.7 times or 18 times, it will exceed the total weight limit. 17.7% chance. Okay. So greater than means exceeding the mean weight. Okay. So let me clarify this. This is greater than. That means exceeds. This means exceeds, higher than. So let me summarize what I did. So I was given the 16 people who are riding a elevator. Maximum weight of the elevator that can support is 2,500 pounds. Okay. And first, it asked what is the mean weight of the sampling distribution. The sampling distribution is a sample mean for 16 people. Okay. And since the weights are normally distributed, okay, since the distribution of weight is approximately normal, the distribution of mean weight is also approximately normal. And from central limit theorem, mu x bar equal to mu equal to 150 pounds, and sigma x bar, which is the standard deviation of the sampling distribution or sample mean weights, is sigma divided by square root of n, which is sigma standard deviation of weights is 27 pounds divided by square root of 16, which works out to 6.75. So the mean of the sampling distribution is same as mean of the population, 150, but the standard deviation is only 6.75 pounds. Now, the maximum weight that the elevator can support is 2,500 pounds. So, if 16 people, if 16 people are put in the elevator, okay, their average weight maximum can be 156.25. Any larger, the elevator might collapse. We don't want that. So, basically, they want us what is the chance of that happening? That the average weight of 16 people will exceed the maximum limit of 156.25. Exceed means greater than. So we are on the right of 156.25. So we start our calculation from 156.25. The right end is a very large number on the right, which is 1e99 or 1 followed by 99 zeros. Mean is 150. Remember, the standard deviation is the standard deviation of the sampling distribution, which is 6.75. And then we paste enter and enter. And we find that there's a 17.7% chance that the mean weight will exceed the weight limit. What does it mean? If you repeat the experiment 100 times 16 people with an average weight of 150 pounds, okay, and a standard deviation of 27 pounds are put in that elevator 100 times, out of 100 times, 18 times or 17.7 times, it will exceed the maximum limit. So, what does it mean? There's an 18% of the chance that is going to happen. That means the elevator will collapse. Is 18% a great chance? Yeah, I would say. Anything greater than 5% is reasonable or is a chance of happening. So 17.7% is a fairly large chance of that happening. So what is the solution for this? Solution is reduce the number of people maybe who can board the elevator. Maybe maximum keep it at 15 instead of 16. Okay. So I stop here today. If you have any question, any comment, any better way for me to solve this problem, please do not hesitate to write me a note. And I really want to hear where you are watching my video from. That really motivates me. If you like this video, give me thumbs up. If you think this is helpful in understanding the concept, please give me a thumbs up. Uh, for sure, I mean, I get more motivated when I see more thumbs up. And if you like this video, share with your friends and please subscribe to my channel by hitting the red subscribe button at the bottom right corner and share the video with your friends. And please do not forget to check me out tomorrow when I'll come back with another video, another interesting situation. Thanks for watching. Take care. Hey, I appreciate the fact that you stuck around and watched the video with till the end. Thanks. Take care. Have a nice day.